Today we continue our study of the mathematics of finance by covering section 11.3 on credit cards and consumer loans. Basic idea with credit cards is that when a customer uses a credit card to make a purchase, the customer is actually receiving a loan. Typically, there's an added cost to the consumer on credit in the form of an annual fee or an interest charge or charges on purchases. A finance charge is an amount paid in excess of the cash price and is the cost to the customer for the use of credit. The most common method of determining finance charges is the average daily balance method. Interest charges are based on the credit card's average daily balance, which is calculated by dividing the sum of the total amounts owed each day of the month by the number of days in the billing period. For example, if I ask you to calculate the finance charge for a credit card with a $117.19 average daily balance and a 1.95% monthly interest rate, all you would need to do to calculate that finance charge is multiply the given average daily balance of $117.19 times the monthly interest rate, which as a decimal is 0.0195. And that gives you, rounded to the nearest cent, a $2.29 finance charge. Finance charges are easy to calculate if you already know the average daily balance, as we just demonstrated. If you don't know the average daily balance, though, you have to calculate it first, and then use that result to calculate the finance charge. This is the formula for calculating the average daily balance. But I'm going to show you that we really don't need to use this formula explicitly if you're willing to use something you already know how to do. So I'm going to display the average daily balance formula, which is really the sum of the total amounts owed each day of the billing period divided by the number of days in the billing period. But then give you the caveat that you really don't need that formula if you're willing to do it another way, which I'll show you shortly. Here's an example. A credit card account had a $246 balance on March the 5th. A purchase of $117 was made on March the 12th, and a payment of $200 was made on March the 28th. Find the average daily balance if the billing date is April the 5th, and round your answer to the nearest cent. Again, I'm displaying the formula for average daily balance, but honestly, if you're willing to use something we already learned earlier, you don't really need this formula. And I'm going to show you through this example what you can do instead. First of all, you need to build a table. The first column should have the dates. The second column should hold the changes in the balance on the credit card account. The third column should actually be the daily balance. And then the last column is the number of days. If you'll build this 4-column table and follow the steps I'm about to show you, the average daily balance follows. First of all, go back and read the problem and find the earliest date that something happened. And what you see is that March the 5th was the first date that anything happened, and that was the credit card balance was $246. So the daily balance on March the 5th was $246. That's your starting point. Now you move on. Look for the next date that anything happened. You'll find it was March the 12th. On March the 12th, there was a purchase of $117. So go down to the next line, put March the 12th. The change in balance was a purchase of $117, so that increases the balance on the credit card. So that's a positive $117. And if you take 117 and add it to the 246 that was already there, you end up with a new daily balance of $363. Now here, pay attention. Eventually, we want to find the number of days that each of those daily balances occurred. So if I look back, I started out at March the 5th. The next thing happened on March the 12th, so I've got to go back up and say that that first daily balance of $246 was continued all the way through March the 11th. It was only changed on March the 12th. So once you put in a new date, you can go back and put an ending date on the old date. So it started out being March the 12th, but it ended on March the 11th and changed from 246 to 363 on March the 12th. Now we need to count how many days that happened. If you just say 11 minus 5, you get 6. But if you look at the actual count, you're counting 5, 6, 7, 8, 9, 10, 11. It's actually 7 days. So remember, we talked about that earlier when we did consecutive numbers. If you subtract the biggest minus the largest, you have to add 1. But if you're in any doubt, just write them out and count them, because you don't want to miss the number of days. It turns out to be 7. Now let's move to the next transaction. You'll notice that a payment of $200 was made on March the 28th. So the next line of the table should be March the 28th. There was a payment, so that decreases the credit card balance. So that's a minus $200. And if you take $200 away from the previous daily balance of $363, you end up with a $163 daily balance. And now that you have that in, you can go back up and see the ending date on the previous line. So if the payment was made on March the 28th, that means the previous daily balance of $363 ended the day before on March the 27th. And now you can count the number of days from March the 12th to March 27th. As I said earlier, you can take 27 minus 12 and add 1, or you can just write them all out and count them. But you have to get the number of days right, or all your other work is for naught. So 27 minus 12 is 15, plus 1 is 16, or you can just write them out and count them. In any case, it's 16 days. And now you look, and the only thing left is the billing date. The billing date, and this is important, the billing date is the first day of the new cycle. So that means that the old cycle ended the day before. So whenever you're given the billing date, you know you need to end the day before that. So that balance of $163 doesn't go all the way to April the 5th. It goes to the day before, because the billing date is the first day of the new billing cycle. Then you've got to count. Be careful. You've got to know how many days each month has. March 28th, 28th, 29th, 30th, 31st, that's March, then 1st, 2nd, 3rd, 4th. That's 8 days total. However you do it, be careful, because if you miscount the number of days, all your other work is going to be for nothing, because your answer will be wrong. And from here, the easiest way to find the average daily balance is to use what we learned about finding the means using the calculator stats mode. So all you need to do is press on the calculator to clear out any old data, press mode period to put it into stats mode, and then enter the daily balance, however many days it was valid. So the $246 goes in 7 times because it was valid for 7 days. And then you move to the next one. The 363 was valid for 16 days, so you type 363 in and hit M plus 16 times. And finally, $163 was valid for 8 days, so you type in 163 and you press M plus 8 times. And finally, to get the calculator to calculate the mean, you do Shift 7. You've already learned how to do this, so taking advantage of that allows you to get the answer without using that formula that I told you earlier that you don't really need. This is the way I would recommend doing it. In any case, when you do all that, you'll end up with $284.97 after you rounded it to the nearest cent for your average daily balance. This is the way I recommend doing the problems, rather than memorizing that formula and using it. Granted, there are some problems where your final answer is just the average daily balance, but in reality, most of the time you're calculating the average daily balance so that you can proceed to find the finance charge. So let's take that problem that we just worked a little further. We just found out the average daily balance is $284.97. Now suppose we know that the interest on the average daily balance is 1.5% per month, and we want to find the finance charge, because that's typically what you do with an average daily balance once you find it. All you need to do is take that $284.97 and multiply it by 1.5%, but remember, you have to change that percent to a decimal, so 1.5% is 0.015, and 0.015 times $284.97 is $4.27. So for that month, your average daily balance of $284.97 would produce a finance charge of $4.27. Now let's discuss something called the annual percentage rate. The true annual interest rate, for short, it's called APR sometimes, or annual percentage yield, APY, is simply the effective annual interest rate on which credit card payments are based. The idea behind the APR is that interest is owed only on the unpaid balance of the loan. We can use the following formula to estimate the annual percentage rate, or APR, on a simple interest rate installment loan. And that formula says that the APR is the quantity 2NR divided by the quantity N plus 1, where N is the number of payments and R is a simple interest rate. For example, you purchase a refrigerator for $675, pay 20% down, and agree to repay the balance in 12 equal monthly payments. The finance charge on the balance is 9% simple interest. Find the finance charge. You have to read through the problem carefully. The first thing you want to do is find the amount of the down payment, because you paid 20% down. That's not even borrowed, so that has to go away. So the down payment is 20%. 20% is 0.20. 0.20 times $675 is $135. So you paid $135 down right up front. That's not part of the money you're borrowing. So you have to take this $135 away from the $675. That leaves you with a total of $540 that you want to finance. So that's the first thing. So the finance charge is 9% simple interest. So 9% of $540 is $48.60. Remember, you're doing it in 12 equal monthly payments, so you're doing it for a year, so that's an annual interest rate. This type problem is very straightforward. You just have to read through and find out what you need to do and do it a step at a time, but none of the calculations are difficult. Now let's estimate the annual percentage rate and then round to the nearest tenth of a percent. The annual percentage rate estimate formula is that estimated annual percentage rate formula for simple interest loan. APR equals quantity 2NR over quantity N plus 1 is what you need, where N is the number of payments and R is a simple interest rate. Well, the number of payments was 12, and the interest rate as a decimal is 0.09. Plugging those numbers in and multiplying up top, you get 2.16. Down bottom, you get 12 plus 1 is 13, because you're doing it annually, 12 monthly payments. And if you do that division, you get about 0.16615. Now take several decimal places here, because you've got to change it to percent and then round it. Changing to a percent requires you to move the decimal place 2 places to the right. Now you're ready to round. If you don't take several decimal places, your rounding may be wrong. So I've gotten 16.615%. I'm going to round it back to the 10th place so that 6 stays, because the next digit is a 1. So to the nearest tenth of a percent, the estimated annual percentage rate is 16.6%. Before we get too far along here, we're going to be doing a lot of calculations where you have to use the calculator correctly and precisely. So I want to talk about some of the things you're going to see and need. One of the things is the calculator's version of scientific notation. Sometimes you'll do a calculation, and because of accuracy issues, the calculator displays an answer that's not obvious what it means. And that is the calculator's version of scientific notation. So I want to show you how it works. If you were to take your calculator out now, and I would recommend you do so, and take 0.095 and divide it by 12 in your calculator, what you will see in the display is this number 7.916666667, and then you've got an exponent negative 0.3. That is the calculator's version of scientific notation, and unless you know what it means, I'm not sure you'll know what to do with that number. So I'll tell you what it means. The 0.3 means that you need to move the decimal place 3 places, and if there's a negative in front of it, that means that the movement needs to be to the left. So that means here that you've got to take the decimal place in 7.916666667 and move it 3 places to the left. 3 because of the 0.3, to the left because of the negative sign. So you move the decimal over 3 places, and you get 0.0079166666667. So that's how you deal with the calculator's version of scientific notation. Now, if it's just an intermediate calculation, you can just leave that number in the display and keep going. But if it's the end result of your calculation, you have to know what it means. Another thing is it's not possible to directly enter a negative number. What you have to do is enter the positive value and then press the plus minus key. That's sort of the switch sign key. So if you wanted to enter a negative 34, you would first type in 34 and press the plus minus key. You cannot put the minus sign in first. You have to type in the positive value and then press the plus minus key. Another thing you're going to find extremely useful are the parenthesis keys, and they're pretty much dead center in the middle of the calculator. They're one row above the red clear and all clear buttons, but they're not directly above them, they're just on the row above them. For example, if I ask you to calculate this quantity as 15 times the quantity 1 plus 0.07 divided by 12, all that raised to the 18th power, on your calculator, here's what you do. Your keystrokes are these. You start off, type in the 15. Now when you put 15 next to a parenthesis, it's what I call an implied multiplication. So you have to press the multiplication key on your calculator even though you don't actually see a multiplication symbol up there. That's what I call an implied multiplication, so don't forget that. Then you enter the left paren. Again, it's on the row above the clear and all clear buttons, right in the middle of that row. Then you enter a 1, then you enter a plus, then you enter 0.07. The slash is a division, so you press the division symbol. Then you enter 12, then you enter the right paren. Now the 18 is up in the exponent, so you have to do something in your calculator to tell it that you're about to enter an exponent, and you do that by pressing what I'm calling the power key. The power key is the X to the Y button, and it's right next to the right paren. So you have to press that key and then type in the exponent. And all that's left to do now is press equal to, and that'll evaluate the entire expression all at once, which happens to be 16.65557736. Practice that because it is a skill that you will need. Now let's do a similar calculation. In fact, it's identical to the previous expression, except I changed the 18 in the exponent to a negative 18. This is a practice on entering a negative number in the middle of a calculation. So you start off the same. You enter 15. The implied multiplication means you have to press the multiplication symbol. Then you enter the left paren. Then 1 plus 0.07 divided by 12, right paren. So far it's exactly like before, and in fact it continues that when you press the power key. So you still need to press the power key. Now you're up in the exponent, but you need to enter a negative 18. As I remarked earlier, you cannot type in the minus sign directly. You have to type in 18 and then press the plus minus key. Now the minus 18 is in the exponent. All you need to do is press equal to, and it will evaluate the whole thing, and it turns out to be 13.0898832. Please try these calculations yourself, because if you can't do the simpler ones, you have no hope of getting this when it's embedded in a more complicated situation. So practice the simple stuff first. Another skill that you'll find you'll need is calculating the value of a complex fraction. In other words, there will be a fraction within a fraction. And my suggestion when you see that is to be sure and add parentheses around the entire numerator and the entire denominator if they aren't already there. I'll show you what I mean through an example. If I ask you to calculate the quantity 0.07 divided by 12 over the quantity 1 minus 1/3 on your calculator, my suggestion, you see a fraction within a fraction, is to make sure that there are parentheses around the numerator and denominator before you even start. Now that you've got parentheses around the entire numerator and denominator, when you start typing this in, your calculator will know to do these operations in the correct order. So you start off, keystrokes, you're going to do left paren, then you're going to put in 0.07 divided by 12, right paren. The fraction bar, the horizontal fraction bar means division. Then you go to the bottom, you've got a left paren, 1 minus 1 slash is a division, divided by 3, right paren, and all you need to do is press the equal to evaluate, and that'll give you 8.75 to the negative 03. Now remember what we said earlier, when you see that, that is the calculator's version of scientific notation, and what it means is you take the decimal place and move it 3 places to the left, so what you end up with is 0.00875. Now that we've taken a little time with learning how to use the calculator properly, let's actually apply it to calculating monthly payments for a consumer loan. And one thing a consumer would obviously be interested in is the amount of his or her monthly payment. So this is an important thing to know how to do. This is the formula, and you see why we talked about some of these other things, entering negative exponents, having a fraction within a fraction. Those are all things we practiced a little earlier, so that when you see it all at once in this complicated looking formula, you feel like you have a chance of doing it correctly when you actually tackle it. So let's look at what each of these letters mean. Capital A is the amount of the loan. Little r is the annual interest rate, or APR. Little n is the number of compounding periods per year. And little t is the time in years. We're familiar with all those letters from earlier work in earlier sections. Let's take a simple example. Tegan wants to buy a new jacuzzi. The jacuzzi costs $2,000, and she decides to finance the jacuzzi for 2 years at an APR of 12.5%. Determine Tegan's monthly payment and round your answer to the nearest cent if necessary. So, we've got to identify all the letters. Capital A is the amount of the loan. Tegan is borrowing $2,000 to buy this jacuzzi, so that's $2,000 for capital A. R is the annual interest rate, or APR. That's 12.5%. Of course, you'll change it to a decimal. N is the number of compounding periods in the year, which if it's monthly will be 12 times a year. And we're financing this jacuzzi over a 2-year period, so T is 2. Plug all those values in there, and now it becomes a calculator problem, and you have to be careful. I would suggest that you go ahead and multiply 12 times 2 and get 24. Actually, a negative's up there too, so it would be negative 24. I'd also remember what I said earlier about when you have a complex expression with a fraction within a fraction, it's always a good idea to put parentheses around the entire numerator and the entire denominator, like so. You'll notice that what I've done so far is just get the expression ready to most effectively type it into the calculator. So I went ahead and multiplied the exponent values together to get a single value, and I put parentheses around the entire numerator and denominator because there was a fraction within the fraction. That's always a good idea. Now the expression is ready to type into the calculator. So you want to type in the 2,000, and it's an understood multiplication or implied multiplication, so you have to press times. Now the next thing you notice is that I have left paren entered twice, and that is because the bracket next to the 2,000 is really a parenthesis. And then when you get up the numerator, you've got another parenthesis. So you've got to enter that parenthesis, left parenthesis twice. Then you type in 0.125 divided by 12. Then you close the top parenthesis after the 12. Then you go to the division symbol, that horizontal bar that divides the big numerator over the big denominator. That's a division symbol. Then you start the left paren in the denominator, and then 1 minus, and then you come to another left paren, so you enter another left paren, then you've got 1 plus 0.125 divided by 12, then there's a right paren, and you see that minus 24 in the exponent, so you have to press the exponent, the X to the Y key. Then you want to enter a negative 24, but remember you have to type in 24 and then plus minus. And once you've done that, you've got the right paren in the denominator, and then you hit that last bracket on the right. The very last thing is a bracket. So that's like a parenthesis again. So you press a second paren, and then to evaluate the whole thing at once, you press equal to. Now this takes practice. If you try this and get the wrong answer, try it again. Read through my keystrokes, see if you followed them. If you find a place where you're making a mistake, try it again. There's nothing wrong with making a mistake, backing up, trying again, but you have to practice this. Watching me do it on screen is not a substitute for you trying it yourself and doing it until you can do it without making a mistake. So practice makes perfect here. And when you do that, you'll end up with, rounding it to the nearest cent, $94.61. So Tegan would have to pay $94.61 a month for 2 years to pay off the $2,000 that she borrowed to buy that new jacuzzi. And finally, as I always recommend, look and see if that answer looks reasonable. That's a little less than $100 a month. $100 a month for a year would be $1,200. For 2 years would be $2,400. So it'd be something less than that. So if the jacuzzi costs $2,000, paying somewhere in the neighborhood of $2,300 principal plus interest doesn't sound unreasonable. So I have no reason to doubt that answer. But if you get a really big answer like $961, then you know that can't be right. So always look and see if your answer at least seems reasonable. Although this formula was introduced as a way to calculate the payment on a credit card bill, keep in mind that paying off a credit card balance is just like paying off a compound interest loan, so you can also use it for that. In fact, you can use it to calculate monthly payments on student loans, or at least some of them. We're going to talk about something called a subsidized student loan that Lois just received. Lois just received a 9-year subsidized student loan of $32,000 at 4.5% annual interest. Determine her monthly payment on the loan. A is the amount borrowed, so that's $32,000. R is the annual interest rate, which is 0.045 after you change it to a decimal. We're doing monthly payments, so N is 12, and we're doing it over 9 years, so T is 9. If you plug those values in, you might notice that this is a complex fraction, so according to my recommendations, you would take the numerator, put parentheses around the entire numerator, and the denominator and do the same, so it would look like that. I also recommend that you go ahead and multiply the exponent values together to go ahead and get that out of the way as well. And if you do that, you'll get a negative 108 as the exponent in the bottom part. Now, the expression is ready for the calculator. Here are your keystrokes. Again, I can't do this for you. You need to practice this over and over again until you can do it reliably. So you put 32,000 in as an implied multiplication. The bracket is a parenthesis, and if you go up top, you've got a left paren, so you end up with 2 left parens. Then you type in 0.045 divided by 12, and then you hit a right paren, and now you go to the horizontal line representing the division of the big numerator over the big denominator, so that's a division symbol. And then once you get to the bottom, you've got a paren, and then 1 minus, and then you've got another paren. These are both left parens. And then you've got 1 plus 0.045 divided by 12. Then you hit a right paren. Now you're where you need to put in the exponent of negative 108. So you have to type in the exponent symbol, and then you have to type in a positive 108 and put plus or minus to make it negative. And once you do that, you've got a right paren, and then you hit that final bracket, which is another right paren. And if you hit equal to, after doing all that, you should, after rounding it to 2 decimal places, in other words to dollars and cents, you would get $360.88. I want to use this problem to talk about a slight variation, so before we leave it, let's look at it a little more closely. Although the monthly payment on this student loan is $360.88, here the problem says that the government subsidizes the loan. What does that mean? That simply means that the government takes care of the interest payments until the student graduates. Until the student graduates, payments are not due. So if Lois graduates 3 years after receiving the loan, she would not begin her $360.88 monthly payments for 3 years. So even though she may have borrowed the money when she started school, or maybe a year into school, she doesn't have to pay anything for those 3 years until she graduated. Another variation is the unsubsidized student loan. For an unsubsidized student loan, the student still doesn't begin making monthly payments until graduation, but the student is still responsible for the entire loan. So if Lois graduates 3 years after receiving the loan and it's unsubsidized, she's essentially taking out a 3-year simple interest loan whose interest accrued is then added to the original amount borrowed when calculating the eventual monthly payment. In other words, she's borrowed that $32,000 for 3 years before she even begins paying on it. So it's like a loan. And in this case, a simple interest loan. So you have to treat it that way. So if it's an unsubsidized loan, let's go back and do the calculation there. If we're reworking this problem as an unsubsidized student loan, assuming that Lois is 3 years from graduation, then for the first 3 years until she graduates, that $32,000 loan accrues 3 years of simple interest. You've got to go back to your knowledge of simple interest loans. Remember, simple interest is I equals PRT. That's 32,000 times 0.045 times 3 because it's for 3 years. What happens for that first 3 years is that Lois is not being subsidized, so she's actually built up $4,320 in interest during that 3 years. So she doesn't owe $32,000 after that 3 years. She actually owes $32,000 plus the amount of interest, which happens to be $36,320 for the 9-year period. Remember, it's a 9-year period. For 3 years, she stayed in school. She wasn't making the payments, but she was taking out essentially a simple interest loan for 3 years. So you take the $32,000 and figure that there's $4,320 in simple interest due at the end of that 3 years. So actually, she now owes, right after she graduates from college, she owes the $32,000 she borrowed plus the $4,320 that she accrued because her loan was not subsidized. So now you go back and do exactly the same thing we did before, except now instead of it being $32,000 for A, it's $36,320 for A. And that's what happens with an unsubsidized loan. The formula is the same once you figure out how much you're actually owing, because 3 years went by before she did anything. Now she's paying back $36,320. So you plug all those numbers in. All of them are the same except for A was $36,320 instead of $32,000. So if you multiply the exponents together and put parentheses around the entire numerator and denominator, then you get the same set of keystrokes. It's very similar to the last one, so I won't repeat it step by step, but you do need to practice this. So pause and see if you can get this answer, and if you don't, start over, try again. You need to practice this until you see what you're doing and can repeat this reliably, getting the right answer. Watching this is not enough. You have to practice. How about this problem? Louise bought a Porsche Boxster for $45,500 and financed the entire amount at an annual interest rate of 4.3% for 5 years. Find the monthly payment assuming the sales tax is 6% of the purchase price and the license fee is 1% of the purchase price. So here they're just adding on a few more things that are going to affect how much you're actually going to borrow. It's a $45,500 car, but it's got to have sales tax and license fee added to that, and you're going to borrow that bigger amount. So first of all, we have to figure out the sales tax. So once you change it to a decimal, you get 0.06, and 0.06 times 45,500 comes out to be $2,730. So the sales tax has to be added on. The license fee is 1%. So 1%, which is 0.01, 1% of 45,500 is $455. So now the total amount borrowed is the price of the car plus the sales tax plus the license fee. The amount borrowed now is actually $48,685. But once you get that amount, that's going to be your capital A, and you'll use the same formula as before. And you plug in capital A is $48,685. The interest rate is 4.3%, which is 0.043. It's for 5 years, and you're doing monthly payments, so N is 12. Plug all those numbers in, and again, you want to put parentheses around the entire numerator and the entire denominator so the calculator knows exactly what order to do these operations in, and you probably also want to go ahead and multiply 12 times 5 and get 60. So at this point, the expression is ready to go in the calculator, and again, I'm going to display the keystrokes and not go through them in detail, but you have to practice this until you can reliably get the right answer. And the answer you're shooting for, once it's rounded to the nearest cent, is $903.21. We've used this formula now for a few examples, but I do want to say that it's also useful for something else. This formula can also be used to answer another common question. How much would it cost to pay off a loan early? Sometimes you start making these payments and you have saved up some money in the meantime, or somehow you've got some cash and you'd rather just pay the thing off. And that would be a very common question. You can actually use this formula to do that, but it would look better if you had it solved for A. You'll also notice that I changed the NT up in the exponent, which used to be in the bottom, to a capital U. And that capital U stands for the number of remaining payments, because in the end, you're only looking how much it's going to cost you to pay it off, so you don't owe the number of payments that you used to owe. That NT represents the total number of payments over the whole life of the loan. But if you've already gotten into the loan, you no longer owe as many payments. That U corrects for that, and it's only the number of payments that are remaining. So it's the same formula as above, solve for A, except for the exponent of that quantity is actually the number of payments remaining, not the entire number of payments over the course of the whole loan. But everything else is the same. The PMT is the amount of the periodic payment. Little r is the annual interest rate, the APR. N is the number of compounding periods per year. Capital U now is the new thing we've introduced. It's the number of payments remaining. So let's do an example. Suppose Allie wants to pay off the loan on a jet ski she has owned for 18 months. Her monthly payment is $284.67 on a 2-year loan at an annual percentage rate of 8.7%. Find the payoff amount. So we want to use this formula that we have on the screen. And then we've got to realize that that U is the number of payments remaining. It said that she's 18 months into a 2-year, which is a 24-month loan. So if you take 24 minus 18, she only has 6 months of payments left. And that's what capital U is. It's the remaining payments. It's still compounded monthly, so N is 12. The interest rate is 0.087, and the payment was given as $284.67. If you plug all those numbers in, you'll get this expression. And notice that it's a complex fraction, so you'll probably want to put parentheses around the entire numerator and parentheses around the entire denominator before you begin your calculation. Otherwise, it works very similarly to what you've been doing. So again, I'm not going to take you through it stroke by stroke, but you need to be able to reproduce that. And when you correctly get it, you should get $1,665.50. And if you're not getting that, try it again. If you make a mistake, try it again. You have to practice these things until you get it right. Practice makes perfect. These are basically the formulas from this section that you will have on the test, and there's an entire formula list and the hyperlink if you go to the PowerPoint associated with this lecture.